Hey everyone, this is Matt Perez with Converge, and welcome to the last video in our Sketchblock series. Now, if you guys have been following along, you might be thinking, well, finally it's coming to an end because we've talked about a lot of stuff with Sketchblocks, and unfortunately, we haven't even covered it all. There's a lot of things that you can do with Sketchblocks, and it's really an underutilized tool. So hopefully throughout this series, you guys have picked up a few tips and tricks on ways that maybe you can use it for your kinematics, your notes and drawings, taking a complex view of a part, putting it back in as a reference. There's all kinds of different things. But today, and for the last topic, what I want to talk about is using Sketchblocks for motion in an assembly. There's a lot of things that we can do with them in a part, such as the kinematics, but in an assembly, we can actually have a motion study. We can apply a mass to the sketch block. We can apply things like forces and springs and dampers and motors. So there's a whole other level of things that we can do with these. If you aren't familiar with layout sketches inside of an assembly, let's take a quick tour on how to make that happen. So we're going to start a new assembly file. The first thing that you're prompted to do when you start an assembly is to create a layout or insert a part or an assembly. If we select the Create Layout option, you are essentially brought into a sketch. Now this is like a 3D sketch on a plane because you can create multiple planes in here, we can make multiple sketch entities, and in general what these are used for is to help locate parts inside of your assembly. But the other thing that they can be used for is to insert or make sketch blocks. Now you might be wondering why we would even bother doing this in an assembly. Well, there are some benefits to having sketch blocks at the assembly level. So we have a sample file, linkage simulation. It's a SOLIDWORKS assembly file, but there's no parts in it. It's all sketch blocks. And we want to take a look at ways that we can edit this layout, some of the parameters that we can affect in here, and ultimately what we can do with this. Just a couple quick notes. I do have tools, add-ins, and motion study as well as simulation turned on. So these are some add-ins that I am currently working with. If you don't have simulation, that's fine. You can still follow along with the video, but I just want to note a few things that we can do. So first, at the top of our assembly tree, you'll notice that we have this icon here. And that's representing a layout sketch, saying that this file does have a layout. We're going to right-click on this, and inside of here, we're going to select Layout. This brings us in and allows us to make edits. All of my sketch blocks are in 2D on a sketch plane inside of my layout. You'll notice that I have a swing arm, a bell crank, a dog bone link, and then I have some lines that represent a shock. If I select any of these sketch blocks, I get properties over here on the left-hand side. Now, this doesn't look very much different than it does inside of a part. However, with these closed profile sketch blocks, you'll notice at the bottom, I have mass properties. So what I can do is I can tell SOLIDWORKS that, hey, this swing arm, it's going to be about 15 pounds. I can move the center of mass location if I need to. I can select other sketch blocks such as this link here and say, well, this is going to be approximately 0.7 pounds. And this link here, this is going to be about half a pound. This is all very important stuff because once we get into a motion study and we apply forces and we look at dampers, having a mass associated with the sketch block is going to help us do things like identify the right spring rate, or figure out how much dampening we need for oscillations in this assembly here. So we're going to take a look at that now that we've effectively changed the mass of these blocks, which are still just sketches. Inside of the assembly, I can grab where the wheel would be on this swing arm, and I can move it up and down so we can see what the motion is looking like. Everything works, the linkage moves, it's attached to the right points, and then I'm going to use Control-Z to undo and put it back in that location. From here, the next thing I want to do is go into Motion Study. Now, if you haven't used motion studies before, that's okay. We're not going to be diving real deep into motion studies, but I do want to make a couple quick notes. First of which, on the left-hand side, we have Animation, Basic Motion, and Motion Analysis. So animation and basic motion are there inside of these motion studies. When you go to your tools and your add-ins and you turn on Motion Analysis, you'll get the third option. The third option opens up a host of different things for us. Animation is something you would really use for just moving your parts around on a screen. Basic motion allows us to do things like, it uses assembly mates, for example. We can add springs and gravity and motors. When we go into motion analysis, it takes into account a few different things. It gets a little bit more accurate in terms of the kinematics, but it also opens up simulation, if you have simulation turned on, as well as something over here that's called event-based motion. So we can essentially change the way that we work with these motion studies, and this isn't really something that we're going to be getting into again because it doesn't really apply to what we're doing here with Sketchblocks, but just note that we do have a couple different layers of using motion analysis. From here, the next thing that we're going to start to do is apply some forces and some dampers. So I'm going to get started by first applying a force. I'm going to apply it at this point, and it's looking for a reference. So in this case, I don't have anything that I can click that's vertical. If I expand the tree and I take a look at some of my options, I just have planes. So if I select the top plane, this will give me a normal to reference for my force. And this makes sense for the force of a wheel on a swing arm. Then I need to determine how much force is actually being applied. If it's a constant force, if it's going to be applied and then removed, if it's going to have some sort of harmonic to it, like a wheel going over a bumpy road. We also have some options for actual data points, so if you're going to be increasing or decreasing the load. What I'm going to do is a step. So force 1 is going to be 200 pounds. The time is going to be 1 second. And then force 2 is going to be 0, and the time is going to be 2 seconds. There's also some more options if we scroll down, like load-bearing faces as references, but again, we're dealing with sketch blocks and not actual parts, so those aren't going to apply to us. If we say OK, now we have something in our timeline. If we use this calculate button, we can then see what's happening. So essentially for that first second, the force is being applied and it's pushing this thing all the way up, and then when it's removed, gravity helps pull it back down. It's always a good idea to double check by going back into the model, going back into your layout, and making sure the properties are applied. So 15 pounds here. If we ever want to come back and make adjustments to that, for example, say try a heavier or a lighter swing arm, we could do that by simply going back into the sketch block. Then we just have to recalculate this here. Now that we have that force applied, we're going to go back and apply a spring. The spring needs some locations, and I'm going to give it this upper point and this lower point. So it's essentially where it's mounting. Then I can determine whether it's a linear spring force, whether it's going to be progressive in nature. And since this is attached to some linkage, we're going to be using a linear spring force. And it's going to be approximately 100 pounds per inch of travel, and we can determine the overall length of it. Right now what we see on the screen is just basically a graphics body. There's not going to be a physical spring that's created. It's only used for representation for us to look at. But if you really want to, you can adjust things like the diameter of it to get it to look a bit more realistic, the number of turns, and the coil diameter, for example. So adjusting all these parameters will help us visually represent the spring, but again, it's really just a graphics body. It's not actually a physical spring there. We can also turn on a damper, and again, this can be linear or progressive in nature. We just need to determine what this damping force is. To get started, I'm not going to look at a damper. I'm only going to have a spring. Then I'm going to recalculate this and play through. So you'll notice that the spring force alone isn't really enough. We need to come in, we need to edit the feature, and we need to add that damper, because in reality, our suspension on our cars and motorcycles and bicycles, it's not just a spring because we'd just be pogoing down the road. So I'm going to add a value of, let's see here, we're going to have 50 pounds per inch per second. And if we generate this, you can see now we're getting a more realistic result. The suspension compresses. As the force is removed, you can see that it starts to slowly go back down to its resting position. So this is what we would expect to see in reality. And again, you might be wondering, why are we bothering doing all this? Well, the first thing is this helps us address not only the size of the damper and spring and the forces associated with that, but also the geometry of our linkage. We might decide to make the swing arm longer or shorter. We might decide to move the location of this linkage mount in this case, or where the suspension actually mounts if we're talking about a fixed shock situation. We might also decide to move the upper mount for the suspension. We might need to move things around, say we're planning out the frame and all the attachment points. The other things that we can do in here is we can actually take a look at results and plots. If we want to look specifically at reaction forces, or if we want to look at displacement or trace path of the linkage, or potentially the velocity of some of the components, we can do that. So we can come in here and we can look at the magnitude or the direction in z or x or y. We can pick a point and figure out how it's traveling. For example, the center point of this link. And what we can do is we can create that plot versus time or versus some new result, and we can reutilize sensors, which we've talked about in a previous blog post video. We can utilize that data throughout the simulation and motion study. So if we say, okay, now we're seeing a plot, and as we go ahead and we scrub through this animation, you can see each point on the plot and exactly what's going on. We can also slow this down. We're going to go at point 1 and we're going to play from the beginning, and we can watch it trace that path, and we can see at full compression we have our max force at 1 second. And at 1 second, that's when it switches to 0, and this is when it starts to come down. Now the linear velocity starts to speed up, but then we also have a damper associated with our spring. So the spring is pushing it down, but the damper is also slowing it down, as well as just the geometry of our linkage. So these are, again, some great tools that we can utilize here simply by creating these sketch blocks, applying some mass to them in the layout sketch, and coming in and just taking a look at them kinematically. We also have the option to set up a simulation. We have to select the things that we're looking at, maybe potentially one of the sketch blocks or a specific point in time that we want to look at. Simulation run inside of a motion study can be extremely helpful. Now, while you can do some simulation with sketch blocks, and we can obviously do the kinematics we've already talked about, this isn't really going to be an option for us during a motion study with our sketch blocks. But keep in mind that if you take this design into 3D and you come back in and you continue on with your motion analysis, we can pick points in time to analyze the stress and the reaction forces based on the parameters that we've set up. If you set up a simulation in SOLIDWORKS and you talk about the contacts and the loads and constraints, that's all taken care of by you simply setting up a motion study and applying mates inside of the assembly. So at this point in time, I hope you guys see that there is a lot of benefit to using sketch blocks for many different things. We've talked about using, again, sketch blocks for just the basic stuff, just creating them, making blocks, reutilizing them for things like bolt patterns. But then the kinematics aspect of it inside of SOLIDWORKS, ultimately going all the way down to the kinematics inside of the assembly. So I hope you guys liked what we've done here. It's a rather long series talking about sketch blocks, but it is a really important topic. We've covered this before in SOLIDWORKS World presentations and through training, and hopefully people are starting to see the power of using sketch blocks for all kinds of things. If you guys have any questions, please reach out to us, of course. And if you have any ideas for blog posts that you want to see, we love to hear them and hopefully capture that in some future series.